across three different agent configurations using the same model, Claude Sonnet 4.6. The results reveal something that neither side of the debate has fully reckoned with. The dominant variable isn't the transport format. It's the client-side execution architecture. Let's talk about what was actually tested. Three configurations: CLI tool, raw MCP, and Code Mode MCP. The CLI approach is the traditional function calling model. Each operation is a discrete tool call. Each tool call requires one LLM turn. Raw MCP connects directly to the Stripe MCP server, injecting full tool schemas into context on every request. And Code Mode will explain this one in detail because it's the most important. All three configurations ran the same 12 Stripe tasks: balance lookups, customer creation, payment queries, invoice creation with line items, subscription management, refund processing. Every configuration passed every task, 12 out of 12 across the board. So the entire story is in cost and efficiency. Are the headline numbers: CLI tool, 711,555 tokens, costing $2.22 total. Raw MCP, 506,970 tokens, $1.60. Code Mode MCP, 294,924 tokens, 98 cents. Code Mode uses 58% fewer tokens than CLI. It costs 56% less for identical outcomes. With the exact same model, if you're running agents at scale, do this math. 1,000 tasks per day at CLI pricing costs about $1,240. At Code Mode pricing, that's $820. That's $152,000 per year in savings on a single workflow. Now here's the twist. If you only looked at simple tasks, CLI would look excellent. Consider a basic balance lookup, a single API call with no parameters. CLI uses about 3,000 tokens. Raw MCP uses 19,000. CLI is 6 times more efficient on this specific task. Why? Because MCP servers advertise their full tool catalog on every single request. The Stripe MCP server has dozens of tools for customers, charges, invoices, subscriptions, payment intents, refunds. All of those schema definitions get injected into context even when you're only going to use one tool. That's roughly 16,000 tokens of documentation that's irrelevant to a balance lookup, paid on every request. CLI tool schemas, by contrast, are handwritten and minimal. A balance lookup tool might be defined in 200 tokens. So if your entire workload is simple single operation reads, CLI looks great. But this advantage evaporates the moment tasks become complex. Let's look at the create invoice task. Create a customer, create an invoice, add line items, set billing parameters, finalize. Multiple API calls with dependencies between them. This is representative of real-world workflows. CLI tool, 19 LLM turns, 497,556 tokens, $1.52. Raw MCP, 12 turns, 168,480 tokens, 53 cents. Code Mode, 4 turns, 38,847 tokens, 13 cents. CLI is 12 times more expensive than Code Mode on the single task. And that one task alone accounts for the majority of CLI's total cost in the entire benchmark. Why 19 turns versus 4? This is the key insight. In CLI, each step in the invoice workflow is one LLM turn. Step 1, create customer. Step 2, create invoice. Steps 3 through 8, add line items. Steps 9 through 12, set billing parameters. Steps 13 through 19, verify, adjust, finalize. By turn 10, the model is reading 9 prior turns of tool calls and results as input. By turn 19, it's reading 18 turns of history. The token cost of the context window compounds with every single step. In Code Mode, the LLM writes a TypeScript function that handles the entire workflow in one program. That program calls the MCP tools internally, in a tight loop, with state managed in variables rather than in the LLM's context window. The LLM's 4 turns are: understand the task and write the program, maybe a minor correction, receive the result, report it. The intermediate API calls happen inside the program's execution, not in LLM context. The LLM can make 50 API calls inside that program without a single additional LLM turn. So what exactly is Code Mode architecturally? Code Mode is a client-side execution architecture, not a model feature. It emerged from the observation that the most token-efficient way to use a capable LLM with tool access is to ask the LLM to write a program that uses the tools, rather than to use the tools directly. The Port of Context PCTX framework presents MCP tools as a TypeScript API. The LLM writes an async function that orchestrates all necessary tool calls, handles state, loops, conditionals. The PCTX runtime executes this in a secure sandbox. The tool calls happen inside the program. Only the final result comes back to the LLM. Code Mode also solves the schema bloat problem. Instead of injecting full JSON schemas for every tool into every turn, PCTX generates compact TypeScript function signatures. A Stripe tool that needs 3,000 tokens as a JSON schema might be 50 tokens as a TypeScript signature. The LLM understands what the tool does. TypeScript types are an extremely dense information format for models trained on code, but context overhead is a fraction of raw MCP. Now, let's reframe the whole debate. MCP is a transport primitive. Full stop. Like HTTP is infrastructure for the web, and no engineer would argue that choosing HTTP makes an application fast or slow. What determines performance is architecture. How you structure queries, how you handle state, whether you pipeline requests. HTTP is a prerequisite, not a determinant. MCP is in exactly the same position. Whether your tools are exposed via MCP or as CLI functions, the dominant cost variable is how many LLM turns the task requires and how large the context window is at each turn. Both of those are determined by your client execution architecture, not your transport protocol. Raw MCP and CLI tools both have the one tool per LLM turn property. Code Mode breaks that constraint. That's the variable that explains the 56% cost reduction. And importantly, MCP server investment is not wasted if you switch to Code Mode clients. The PCTX framework wraps existing MCP servers. It's a client-side change, not a server-side change. Your Stripe MCP server keeps working. You're only changing the execution strategy above the transport. So what's the practical guidance? Use CLI tools when your tasks are genuinely single operation, one or two API calls with no intercall dependencies. CLI's compact schemas make it the most token-efficient choice in that narrow scenario. Use raw MCP when interoperability is the priority, or when the MCP ecosystem already has the server you need. Hundreds of MCP servers exist for popular services. Using them is faster than building CLI wrappers from scratch. Use Code Mode when tasks involve loops or conditionals, when complexity is variable, or when you're operating at scale. Any workflow where you're saying, do this for each item in a list, is a Code Mode candidate. Multi-step write operations, creating entities, relating them to others, sequential dependencies, Code Mode's efficiency advantage is decisive. The smarter approach is to route by task type. For simple reads and single operation writes, CLI is fine. For anything multi-step, especially loops or more than 3 sequential API calls, route to Code Mode. A simple heuristic on estimated step count captures most of Code Mode's savings. The broader lesson for AI engineering. The community has been optimizing the wrong variable. The explosion of MCP server development addresses a real problem, interoperability and tool discoverability. But it doesn't address the cost and efficiency problem that teams building production agents actually face. The surface debate is CLI versus MCP. The underlying question is whether your client collapses multiple tool calls into single LLM turns through code generation and execution. That architectural choice is where the economics are determined. When evaluating any agent framework, ask, does it support Code Mode execution? What is the schema injection strategy? How does context grow with task complexity? The answer to those questions matters far more than whether you've chosen CLI or MCP as your transport. Read the full analysis with all the benchmark data and methodology details at ThinkSmart. Life/research/posts/CLI vs MCP vs Code Mode.